Hey guys, welcome back to another episode of Simuleo. So today, we're basically continuing what we did yesterday, right? So here's the thing. It's been a while since I streamed, right? Everyone knows that. So here's the thing that I'm going to do today. We're going to be kind of putting everything together. So a few months ago, I guess, I started this project called the Arcane Algorithm Archive, where we were going to put basically all the algorithms we've ever covered on this channel. Now, right now, let me just Google Arcane Algorithm Archive. Yeah, there it is. And right now it's not quite there yet, right? So we go to read, and here's what we got so far. When you take a look at the content, let's just click on Gaussian elimination. For some reason you have to press F5. I'm not exactly sure why. We'll deal with that later on in the week. But you do get, in the end, some sort of visualization of all the different, or some of the different algorithms we've done. And here's the thing. This is some crappy pseudocode. Not a big fan of the crappy pseudocode. Hey, Law Center, and I'm not really sure the best way to use this pseudocode. So what I was thinking was, why don't we give everyone the opportunity to write their own code in their own language? So what I wanted to do was spend a week on Twitch, writing the article, simulating stuff on my own, getting things ready on the back end, put a video out on YouTube, and in the video on YouTube, ask people to basically submit their own implementation of the algorithm that we're covering. That's the idea here. And so in the end, we're combining Twitch streaming with YouTube videoing, with Algorithm Archive writing, and I think putting it all together, maybe this will be an interesting experience for people to take part in, or maybe not. I have no idea. We'll see how it goes. But that's the idea. So what is the first algorithm we're covering? The first algorithm is going to be the Verlet algorithm, which is one that we've done many times before. But I'll go ahead and cover it again one more time, and then we can get started with the implementation of what we're doing today. So let's go into Zernal. Now, for some reason, there's a bug with Zernal recently. If I just try to write on it, it doesn't work until I turn it off and on again. Not exactly sure what's going on there, but it's been doing that for a while now, so whatever. I should have just turned it off and on again before starting the stream, but I don't know. I just decided to start early. So what do we have here? Verlet integration. Okay, here's the idea. We have some sort of kinematic equation. X equals x naught plus v naught t plus 1/2. Oh my gosh, come on. 1/2 a t squared. A could be anything. Here's the kinematic equation. What we say is x of t plus delta t, that's t with a positive delta t, is going to be equal to x naught plus v naught t plus 1/2 a t squared. Well, these t's are actually delta t's. Right. Okay. And if we do x of t minus delta t, now the delta t becomes negative. That's an x. And we get x minus v naught t, delta t, plus 1/2 a delta t squared. So this means that these guys cancel out. And if we're solving for x of the next time step, we get x of t plus delta t is going to be equal to negative, or let's just say x naught, whatever it was originally, minus x of, 2x naught, minus x of t plus delta t, minus delta t, geez, I'm screwing up a lot, plus a t squared. Okay? Delta t squared. There we go. Should be right. So basically what we've done is we've taken our kinematic equation, and we found a way to basically find the next time step by just knowing your current position, the previous position, and an acceleration. So we do not need our velocity. If we want velocity, we can either find it with v naught plus at, or v equals x, I guess minus x over delta t, right? So these are x's of two different times points. So that's kind of what we're looking at here. It's quite interesting because we can use it for a number of different things. Like, for example, if you want to drop a ball from 5 meters, that's one thing, and that's what I'm going to tell everyone to do. But the thing we want to do today is some sort of gravity visualization of sorts. So obviously gravity is going to be equal to g m over r squared, which is g times the mass of one object times the mass of another object over r squared. G is some sort of constant, right? Const. Okay, so here's the idea. We have some sort of box, and in this box we have a bunch of planets, something like this. Okay, we want to shoot an asteroid through these planets to the finish line over here. So what we want to use is we want to use the gravitational pull of these planets in order to get our asteroid to the finish line over here. That's what we're hoping to do. So I guess I'm going to go ahead and try it. We're going to do the visualization in OpenGL. We can start the asteroid from anywhere on this side, right? So we kind of choose where we shoot it, and it kind of lands over here in some weird way. It's just a little mini game I guess we can use in order to better explain, I guess, just force integration and stuff like that. But we'll be using Verlet integration to do so. So that's interesting. Later on, we'll probably be using the same visualization for the Barnes Hut algorithm, which is the algorithm, if you remember, that we used to turn an n-squared process, which was basically force integration on a grand scale, to n log n. So basically we split the system up into a bunch of quad trees and we work from there. That's kind of the idea here. So we're definitely going to be using this visualization more than once, and I kind of want to go ahead and get it written down once and go from there. So first, let me get a quick sip of water, and then we can go ahead and get started. And we'll see how it goes. Okay. Oh, one more thing, guys. So I mentioned recently that my YouTube channel recently hit 7,000 subscribers, and in part that's the reason I continued streaming again. You know, I decided, you know, I have some popularity here. Not so much on Twitch, but a good bit on YouTube. And I thought to myself, yeah, let's go ahead and keep going. But I thought I wanted to change the way that I was making my videos. Because what I had been doing before is anytime I'm speaking to the viewer, I put my face on the video. You know, it's me and the viewer, we're talking. You know, anytime I was showing something, like mathematically, or just something I thought deserved to be on a chalkboard, you know, something I could describe on a chalkboard, basically still images, but images that I wanted to show me drawing, you know, these would be on a chalkboard, and then anything I felt needed to be animated, like, you know, eigenvectors, fourth dimensional visualizations, things like this, those would be done with code, so I do the visualizations there. And I thought, you know, maybe I didn't want to do this, maybe I wanted to change it up, do everything just with visualizations, everything is just animation. But I don't know, I looked at it. I'm a big fan of the videos I made, actually. And that was a really good, I guess, idea I had last night. I was thinking about it, and I really do like the videos I put out on YouTube. I like the stuff I put out on Twitch, actually, too. Although every once in a while it's kind of cringy when I forget how to do basic programming, but that happens, you know, it happens to everyone. So, I guess my point is, I want to continue doing this kind of outreachy type of stuff. I know it's kind of weird right now, in that, I don't know, I don't know, I kind of like the fact that Twitch is kind of lower viewership, but, you know, everyone's very active, you know, that's quite nice. I like having a small community of people to work with. Yeah, so anyway, this is kind of the ideas for the future. I just wanted to throw it all out there. Let's go ahead and get started. So CD projects, SciVL. If you guys remember, SciVL is a scientific visualization library, projects, SciVL, that we have been using to do a lot of previous visualizations. For example, the Fourier visualization, SciVL, -S Fourier, gives us, here's our visualization. So here we see the wave on the left and the frequency space image on the right. If we go up and down, we see different images over here. Now, there's a couple things I'm not a big fan of with this visualization in particular. One of which is how we draw lines. I don't know. I'm not the biggest fan of how we ended up doing it. Just because I couldn't figure it out. So obviously OpenGL has OGL draw lines or whatever, which works just fine. No problem with it. Except for the fact that it really doesn't work with line width for Mac OS, and I couldn't get that to work. So I ended up implementing my own line drawing system or something like that. Anyway, regardless, that's something we need to fix in the future. For today, we're going to be working with a new simulation, and this simulation will be called Verlet. And right now, it's just the test animation that we have before, just to show that we can do animation, which is kind of nice. all we're going to be needing for this simulation is the circles, right? We don't need anything but the circles. We're just going to draw a couple circles, shoot some stuff, see what happens. So let's go ahead and get the circles drawn and go from there. So VI source, and we want to go into, what's it going to be? I think it's going to be distributions, and we go down to Verlet, which should be down here. Now again, as I mentioned before, all the different distributions are all different simulations. So here, if we wanted to run, I don't know, platformer, which is another simulation. Here's our platformer. It's kind of crappy. We're working on it. It doesn't really make very much sense, but we have some guys jumping around. It's rather straightforward. Now I mentioned I want to start doing more animations on this channel, and that's totally true. I do really want to do more animations, but at the same time, I don't want them to be complicated animations. You know, there's a level of artistic detail that I think distracts from the point that I'm trying to make. Like, if I'm trying to show a physics simulation, I should show a physics simulation. I shouldn't show some sort of incredibly complicated, you know, background drawing thing. You know, I should be drawing the physics simulation, you know? And it's kind of my opinion that as we start doing more of these animations, we'll get better and better, and we'll reach a point where we're a little bit more complicated than we are now. You know, we have more visualizations. Like, it's more robust than it currently is, but at the same time, I don't want it to be so much more robust. You know, I don't want it to be crazy complicated. Okay, so what do we have here? Well, in the Verlet function, all we do is draw the shapes. So basically what we need to do is just put the shapes in the appropriate spot. Now, what are we doing here? There's a few things about the scientific visualization library that we have right now that I'm not a big fan of, but we'll go through that as we go through it. So, first thing first, how we do animations. Animations are quite good. I think they're fine. Basically, we can create a circle, and add in keyframes for when we want the circle to draw, right? So, for example, if we want a bunch of different circles, let's just put these guys in different spots. So what do we have here? Create circle, an array, resolution, where's its position? Circle color, that's fine. Array 1, array 0. I'm reading in array 0. So let's go ahead and put in a couple different positions here. Where's array? Array is here. So we want 4 circles, so let's change this to 4. So this is going to be 4 different positions. And these are just going to be 4 different positions of circles that we're going to throw in there. So let's do paste, and let's just change these guys around. So let's put them at all 0.5 here, another 0.5 here. This is, of course, 2D. So let's see. Oh, that was meant to be a 5. There we go. So 0.5, 0.5, 0.5, negative 0.5, negative 0.5, negative 0.5, and negative 0.5, 0.5. These are all the different positions. Let's get a whole bunch of different colors here. So we want to do, let's do the same thing we did before, where we have some sort of GLM vec3. So this is for the colors. So std vector. Oh, that's not how you spell vector, is it? Vector of GLM vec3. Okay, and these are for the colors. So we're going to say array for color array, because I'm very original here. And we're going to say carray 4. Okay, so what we want to do is say carray. 1 second. And we're just going to give it all the primary colors here, just for simplicity's sake. So we'll say 1, actually 0, and I forgot I need to change these to R2 and R3. And let's just go ahead and yank paste here. So let's do 1, 2, 3, 4. R1, R2, R3. There we go. Okay, so what colors do we want? It's RGB. So the first one we'll say is red. The next one we'll say is green. So let's do, I guess R1 here. Oh, that was an R. Okay, R0 there. The next one's going to be blue, so let's just go ahead and change this to a 0. And the next one we'll say is purple. Okay, so now we have all the different positions. We just have to create all the different circles and add the appropriate keyframes to them. So let's do it. We have the circle resolution. I think, what is 0.25? I don't remember. Let's go into VI source, shape functions, which is where we keep all that. Ooh. CD, oh. Shape functions. I have 2 shape functions? Oh, let me just remove source shape functions too. I think that gave me problems 2. That's CPP. I don't think it's necessary. Hopefully not, because I just removed it. And if it is necessary, then I'm screwed. Let's go down here and let's say create circle. Yep, okay. So radius, that's what 0.25 is. Great, so that means it's going to be relatively straightforward to work with. So we're going to remove these guys here. Yep, that's what I want. And this is basically our setup. So what we're going to do is we're going to create the circle. We're going to add in keyframes, which are going to be when the circle is being animated type of thing. And then we're going to push back the circle in our group of shapes. So that's what we're working with here. Let's go ahead and set this up. So it should be C array of 0. And this, I think, should do it. So let's go ahead and do yank 3 yank. Let's paste it down here, here, and there. Okay. So this will create all different circles, but they're all going to be of the same type. So what I want to do then is change this to 1, 2, 3. So let's go here and let's do R1. Change this to 1 here. Hey Bugsby, what's up? Go down here, change this to a 2. And change that to 2. And then go down here and change this to a 3. Okay. So what do we want? We want to draw these at different times. So let's go here and let's give these guys different times. So we're going to say this one's going to be drawn between 0 and 1. Actually, no, let's do 0.25. Oh, that wasn't what I meant to do at all. I'm sorry about that, guys. So let's go 0.25. Okay, so this one's going to be drawn from 0.25 to 0.5. This one's going to be drawn from 0.5. Oh, what is going on? What am I doing with my life right now, guys? Okay, pop it down here. I'm sorry. This one's going to be drawn from 0.5 to 0.75. And the last one's going to be drawn from 0.75 to 1.0. Okay? So this should, unless I'm completely wrong here, compile. And then after it compiles, we should be able to draw it, and we should just see 4 circles appear. So let's do SciVL. Oh, that's not how you call it. SciVL -S, and we want to run Verlet. Okay, there's our 4 circles. Great. Okay, so in the end, what we're going to want to do is kind of make a little game here, right? So we want 3 circles to be planets. We want some sort of shape down here, which symbolizes the finish line, I guess you could say. And then we want another one of these shapes to be the asteroid that's kind of moving through these planets, right? So this means we probably want some unique shape for all the different planets and stuff. We probably also want the shapes to be of different size. So let's see what we can do here. We're going to try to really play at the planet feel. So these planets probably want to be I don't know, some weird green-blue color or something like that. We could, in principle, like put some sort of map on there to make these guys like we could put a material on them, so they actually look like shapes or they look like planets. But I'm okay with just keeping them a standard color for now. So let's see, what do we want to do here? Let's give these guys all different shapes and make them all like a gradient of the same color. So we'll say probably like blue, purple, something like this. So 1, 2, and 3 will be the planets. So we're going to say, this is going to be red, green, blue. So let's change this to, this would be purple, but we want it to be a little bit darker. So let's change this to 0.5. And 0.5. Sorry, I'm just kind of playing around. So right now, I guess there might be not so much interest in here. The next will be, we probably want this one to be straight blue. Well, this is green. Well, we can make it green and blue. Yeah, that's the thing. 0.5. 0.5. And then this one down here is just blue. Let's make it a little bit darker, 0.5. And the asteroid we're going to want to be white. Okay. Let's go ahead and make that again. I don't know why index number appears. That must be in the... Yeah, okay. Yeah, fine. It's good enough. So what we want then is the asteroid to be much smaller and its position to be different than the other ones. So let's go ahead and give these guys different positions. So our array 3, this is going to be the original position. So we want this guy to be -1 in X. This means it's all the way on the far left side. And then we want this position, we can keep it 0.5. Its size should be different though. Its size should be 0.1 or something like this. Okay, Now the size of all the other guys should be quite big, so let's change this to 0.5, 0.3, and this one I guess we can make kind of smaller, 0.2. Well, if it's a planet. Yeah, it's okay. Let's give you guys slightly different positions too. So array 1, we're going to put this one all the way on the right side here. So it's going to be 1, and we're going to put it all the way up, 1, 1. The next one, let's see, where do we want this one to be? Well, let's go ahead and run this, see what it looks like right now. Make. Give this guy a second. Okay. What do we want? Let's, Okay, if I want a finish line down here, and I want this guy to be shot, he's going to be pulled in to this giant planet up here because it has the... You seem to have gotten your presets back? Hey, Slayer Darth, you mean for the music and such? Yeah, probably. Okay, so here's kind of the idea. Watching you in glorious 720p. Oh, I see. Yeah, so I guess just because we had 10 viewers or something like that yesterday, I don't know how many people we had, but we had enough. Okay, so again, this is kind of what we want to do. We want this object here to be shot and hit some sort of finish line that we're going to put down here. Okay? So, how are we going to do that? Well, we have to create the finish line. That's fine. The finish line's not going to be a big deal. We probably want a big planet down here. So let's go ahead and put one of those down there. So what do we want? Big planet, big planet, big planet. What am I doing with my life? I don't know anymore. And I see you have retained your boyish good looks and trendy dress sense. Oh, are you talking about my, my glorious, Actually, this isn't even a Hawaiian shirt. It literally, you can't see it, I'm sure, on the camera, but it just has fish on it. Like, that's all it is. It's just a shirt with fish on it. And I'm not really even a big fan of fish, you know? I don't eat them or anything. So, I don't know, it's a thing. Okay, so, let's go ahead and put these planets somewhere else. 0.5, 0.5, let's drop this guy to... Oh, I don't know. We'll put this guy also at 1, but we'll drop him to the bottom, so we'll say -1. And then we'll also put this guy at -1. Just putting them at easy spots right now. -1. Okay, write this. Go to, what do I want? Make. Yeah, they put fish on everything, like fish flakes on everything. Okay. So let's go down here and let's change the sizes. I actually want the biggest one to be down in the corner. So let's change this to 1. And this guy will be... Let me think. What do I actually want? I want it to be... Yeah, something like this should work. Doesn't matter. At this point, we're just going to have this planet feel the gravitational pull of other planets, right? So what I want is this guy to orbit this guy and like land on the finish line or something like this. I haven't quite figured out the best way to do it. Maybe the finish line should be over here, and so it kind of goes over here, and then it feels the pull of this guy over here. So I haven't decided. We'll figure it out. Point is, we now have to move the shapes. Also, you're making an Agar.io type game. I'm just... So again, as mentioned at the start of this video, we're going to try to combine all of the kind of projects we've worked on so far. So the Arcane Algorithm Archive, again, I've kind of missed social interaction for the past few months. And there was one project that we started on this channel that I didn't want to die, and that project was the Arcane Algorithm Archive. And it's one of those projects that I know probably no one else really appreciated, but I really wanted it to succeed, and at the very least, it would give me a better understanding of all the different algorithms and stuff we would cover. So, I decided, I'm going to get this guy back up and running. Every week, my goal is to go through one algorithm. The algorithm we're going through this week is Verlet integration, which is a type of force integration. So, very simply, we could drop a ball from 5 meters up, show that it hits the ground in 1 second. Easy enough, simple test. But I kind of wanted a more complicated test, so I figured the more complicated test would be a visualization of an asteroid moving around multiple planets. And what I wanted to do was have a finish line over here, and just basically show the object moving around in different gravitational fields. That's all I really wanted. And the reason I wanted that was just because I felt like it'd be a good idea. So we'll see how it goes. So here are the different planets. I realize they're kind of silly representations of planets. I get that. In principle, we should put a texture on them, but I don't know, guys. there's a certain aesthetic that I go for in most of my visualizations, and I like them to be straightforward and simple to understand. Okay, now here, what do we have? We have a couple different functions to play off of. We have move shapes, which will just move the shape to a certain point and such like this. We have the positions of each of these guys here, which at this point is rather straightforward. We know where they all are. So now we have to talk about the next part of the scientific visualization library that I'm not a big fan of. But first, let me get a quick sip of water. Oh, also, as we start making more of these visualizations, they're going to become more and more game-like, I guess you could say. You know, in that they will be played, well, like games, basically. But in the end, they're still visualizations of scientific concepts. And this is something I'm trying to figure out the best way to deal with right now. Yeah, let me try changing this resolution, by the way. Let me just try resolution. Let's do 500 by 1000. Yeah, okay. So this is the thing. Let's do 1000 by 2000. Oh, I think I did it wrong again. 1000, 2000 over here. Yeah, okay. So the problem is, I'm not really sure how to draw objects that don't stretch, you know? Anyway, it doesn't matter. Point is, yeah, so these visualizations will become progressively more, like, telling, you know? So, like, you can play the game and understand the concept type of thing, too. And I kind of wanted to wrap it all together, you know? We've got the scientific visualization library, we have the Arcane algorithm archive, we have everything. So, let's just do it, you know? It seems straightforward enough that we could probably make it all work together. Okay. So, what do I want to do here? I'm going to show you guys the part of the visualization library I'm not a big fan of. But first I'm going to go into VI source, GL setup.cpp, and I went into the wrong file. VI include GL setup.h. Okay. So, how am I going to put this? The scientific visualization library is able to pull a lot of different simulations, right? And I've shown you guys that, right, already. So you can run SciVLS Pong to play Pong, Fourier to play the Fourier transform visualization. You could use it to play whatever you want, you know? And because of this, there's a bit of code that I wrote in that I'm really not a big fan of, but it's the only thing I could think of until this point. Every one of these visualizations require different shapes. They require different different parameters, right? So some require, you know, lengths, width, and heights, and that's it. Other ones require precise positions of different objects and stuff like that. And it's quite complicated. So what we have is this void std par, which is the standard parameter set, right? But as you get more complicated, like here, we have different parameter sets for different things, right? So for Pong, for example, we have the position of the right and left bumper, a radius, a position x, a position y, a velocity x, a velocity y, all this type of stuff. So now the question is, what do we do? What do we do here? Well, okay. I'm gonna try. So what I've done is, because all of the different functions, all the different simulations require different parameters, I kind of put all the different parameters into some sort of big map that everyone has access to. So the struct param has an unordered map, integer, boolean, double. Well, if you need to find a good C++ project, I don't know, man. There's a lot of good C++ projects out there. I gotta admit, C++ is one of those languages that it's a little hard to use, a little unwieldy, but it's kind of fun, you know? Okay, let me go ahead and turn the air conditioner on here because it's a little bit hot, and then we can go from there. Okay, so yeah, that's kind of what we're looking at here. So let's go down and let's take a look at what we have right now for the Verlet parameter set. Yeah, so here's, for example, the parameter set we have just for platformer, right? There's a lot of different things. and it gets quite unwieldy, and there's a couple things I don't like about this. One is that I'm relying on strings here to call from the map, okay? I don't mind the fact that we're using a map so much, because it's a bit of a pain that we have the cost of calling from the map. We could change this to a vector, but I tried a bunch of different things here. I tried using, instead of using a map, I tried using a vector and then having an enum that I called all the variables in from, right? However, enums are not supported to be put into how do I put this? Put into structs. So I ran into an issue there. I don't find C++ particularly different. It's just that most personal projects that I would tend to use C++ for, I code them in Python instead. Yeah, that's fair enough. Everyone has their own preferences, you know? I tend to just do everything in C++ nowadays. I don't know why, it's just something I got to. So let's think about all the different parameters we'll need here. So I guess we'll keep the parameter, I guess, set that we have right now, with the understanding that it's going to get a kind of more complicated from here, and we're going to have to probably fix it in the future. So basically we're putting in a little bit of technical debt here, and I do understand that, and I would like to fix that, but oops, that was not what I meant to do. But we'll get to that when we get to it. So for now it's going to look a little ugly, and I understand that, and I apologize for that. Okay, let's pop down here. That wasn't what I wanted. What happened? Let me scroll up a little bit. And I want to grab... Why am I scrolling instead of searching? I don't know what I'm doing. So let's go ahead and yank to yank. G. Scroll up a bit. And let's do par here. Why? Why is it not grabbing what I wanted to grab? I said yank to yank. Am I on caps lock or something? No. Okay. Regardless, I got what I wanted here. It's fine. Most programming constructs are generally the same, although some languages have their own takes on some of the constructs. Yep, that's totally true. I mean, you can go from language to language without any problem. It was something I actually wrote about in the Arcane algorithm archive. I kind of thought about, how am I going to put this? I kind of talked about choosing a first language. I'm going to be honest, one of the hardest decisions I had to make as a beginner programmer was the choice of language to start with, because I know it doesn't matter. Like, as someone who does a lot of programming, I know it doesn't matter. But it's akin to choosing a class or something in an RPG or something like that. You know, you have to pick something that you think will represent you as an individual, in a way. And at the same time, you don't know what all of the different classes are. You know, you don't know what a warrior is. You don't know what a thief is. You don't know what any of these are. So you pick one at random and you go. But at the same time, in a video game, you can pick a random class and you can just play with it. But in real life, it takes months and months and months to learn your programming language. So if you don't like the programming language you chose to start, there's a bit more of a cost there, you know? And so I found it really difficult when I initially chose my first language. I didn't know the best way to do it, and that was kind of what I thought. Now the thing is, I think Gusman said that he first started programming writing mods for an MMO he was playing. Yeah, it could be true. I mean, I think it's true for a lot of people. In principle, I first started programming because I wanted to become I wanted to be a video game developer, but then I kind of messed around with it and I realized, I don't know, I kind of like programming more than video game development, just in general, and I don't know, it got kind of confusing. But yeah, and I guess if you're writing mods for your favorite video game, the choice of language, that choice isn't something you're going to run into, because your language will be specified by the game you're playing, right? And I think that's generally true, you know? Most people, I think, when they start programming, don't really get the choice of language. Either they're given Java in college because that's what they were given, or something like that, you know? Not sure. Anyway, let's go in here and let's see what we need. So, we have multiple different objects, right? HTML, hello world. HTML is another language I learned way back in the 2000s something. I don't know. It was one of the first things that I learned because I knew that if I made a video game, I'd need a website to promote the video game. Plus, there were a lot of games that were up on like Albino Black Sheep or something like that. So I thought, I should learn HTML so I can make a website so that I can I don't know, make video games on said website. I was really, I didn't understand anything. Like, I was the most noobish of noobs, and I had no one to help. So I just kind of learned on my own, you know? But I think that's true for a lot of people. I just don't know how true it is for everyone, you know? Okay. So let's go here, and let's change par.disk to Verlet. Okay, so what do we have here? We have a couple things that we need to keep track of. We have positions of all the different objects in of all the different planets in our scene, right? We also have the position of our asteroid, position X and position Y. Okay, so what we probably want then is some sort of XYZ position, right? Seems simple enough. And then a map to put all these positions into. Yeah, I think that's a good idea. That way it's rather straightforward to work with, I think. Okay, so let's go in here, because this way we actually have positional objects anyway, so I think it's probably good to have. My career is web development oriented, but I decided to learn, compile, and interpret a language at home, such as Python, C++, etc., because I wanted to understand how things work under the hood. Yeah, so I actually, a long time ago, I used to run a blog where I made, like, different stuff. Like, I made a LAMP server, for example. It was actually a lot of fun. I really enjoyed doing it. Will I do it again? I don't know. Probably not, but that's okay. Okay, so what do we have here? We're going to want to have... let's just go up here and create another struct. So we're going to say struct position. I guess we're just going to do position here. And we're going to have it there. That was an L. I wanted a semicolon. There we go. And in here we're going to say double X, Y, Z. Okay, so that gives us the position X, Y, Z of all of these guys. Now we're going to pop down here, and we're going to create two more maps, which I know is confusing and annoying, and I apologize for that. We're going to have a P map, string, and then we want position, and then position star here, and this is going to be P map and PS map. Because look at how great I am at naming things. So what we want to do now is very quickly write this, go over here, make clean, and then make that, just to make sure everything's good to go. At the moment, I'm writing a wiki template engine for Python, or at least I'm trying to get the project sorted, because I tried to set up an internal use wiki for our company, but MediaWiki is derping. Yeah, I know like nothing about web development or any of this kind of stuff. So it's definitely something I should look into, but I don't currently know anything about. Okay, so what are we going to do here? We are going to create a couple guys. So we're going to say position, actually position star, and what we want this to be is a list of all the different positions. MediaWiki is what powers the ArchWiki. Oh, fair enough. Buttercake, yeah, you're late, but not by that much. It's 5:40 in the morning, so I've been streaming for about 40 minutes. But don't worry about it. It's good that you're here. Right now we're making a simple game where we have like an asteroid just kind of move around in some sort of field. Okay, so we have a couple different positions here. Let's go ahead and put it in. So let's say position star, and we're going to say objects. Yeah, something like that. Objects, and it's going to be a size 4. What am I doing? Because sometimes you, hey, that's your fan, 2 streams in a row. Yeah, right, it's been forever. I'm very sorry. Because sometimes you don't need to reinvent the wheel. You can just write a better version of something, like how Yahoo Answers used to be the go-to Q&A forum on the interwebs, and now it's been usurped by Quora. Yeah, that's fair enough. Actually, I go to Quora quite a bit. That and Reddit and a few other places. Hey, that's your fan. Thanks for coming in. Okay, so what we have then is a bunch of different positions for all the different objects. I'm gonna put these objects in the same like kind of way that I put all the shapes when I initialized everything. So let's do it. What I want to do is malloc. Maybe I shouldn't malloc. Maybe I should new. But I always forget how to do new. What is it? I can look this up though. So let's go into VI projects. I wrote this a while ago. I still go to Yahoo Answers for a good laugh. Yeah, have you guys seen the troller? His name is Ken M. This guy's great. Ken M. Let's see, where is it? Here's a Reddit with him in it, a subreddit. But he just has like the trolliest stuff. You know, it's like, I don't know. The Obamas arrived for their annual Christmas vacation in Kahlua on Saturday. More reasons for folks to vote no Obama in 16. And what a moronic thing to say, shame on you. Christmas is supposed to be a day of rest, not a time for vacation. He's not running, Grandpa. I know, but folks can still vote against him as a write-off candidate. I don't know, I really like this guy. He's great. There's one that he wrote at one point. It was like, find gifts for both cat people and dog people. And then he wrote in the comment section, don't forget about the mole people that live in our sewers. And I just, every time I read it, I can't help but laugh. This guy's great. Okay, what am I doing again? I want to go to projects and I want to go to GPU group. This is just where I put some stuff. Intro, open, CL. What do I want? I want vecad.cpp. Yep, okay, fine. And I'm just gonna look for new because I always forget how to run this. So it's literally just new double N. Holy crap, it's that easy. So we're gonna say objects. It's gonna be equal to new position of size that we want, and it's going to be of size 4. Good, got it, done. Easy enough. So let's go ahead and put these guys in their appropriate positions, which is going to be position. What's the easiest way to do this? We have a .x, .y, and .z. I guess we're just gonna say position 0. I guess objects 0. What am I doing? Why am I so bad at this all of a sudden? Objects 0. .x. Yeah, let's do it this way. Can I do it this way? I don't know if I can. We'll see what happens. Make that. I think I didn't create the appropriate constructor for that. Well, it seems to compile. Oh, maybe it's okay. There we go. So now we want 1, 2, R1, R2, R3. Oh, I just realized. Oh, what am I doing? What am I doing? I just realized we have vec3 for this. We already have this existing. What am I doing? Gotcha. Hey, Antrophis. What am I doing? Let me go. GL setup.h. Let's roll down here. Okay, we have vec3. I don't know why I'm using position when we can't just use vec3, and we can just have a list of vec3s. Whatever. Yeah, I'm sorry. Entrophist, Speckledmon, thanks for coming in. Okay, wait, did I misspell Speckled Lemon? Speckled Lemon. Oh man. Why did I have trouble with that one? I thought it was like a Digimon. Let's go ahead and remove this guy. Let's go back here and let's solve our issue because I don't know what I'm doing with my life. Okay, let's go here. Let's change this to a vec3. It's going to be GLM vec3. Go over here, GLM vec3. We could just keep a vector of vec3s. Let me think here. For all the different positions. Actually, yeah, I think that'd be better. Let's just keep a vector of vec3s. Yep. Pop down here, vector shapes. Let's go down here. STD vector of GLM vec3. And we're going to want this to be positions. That seems really long. Pauses, locations, whatever. Positions is what we have. Let's go with that. I'm not gonna play this much more. This makes things way cleaner. Okay, so what do we want to do then? We want to put in a bunch of different positions for all the different objects starting location. Got it. Okay. But I'm also going to in here put in another map. So std Let's just DD here, yank, paste. There we go. No reason to beat around the bush. So we're going to do vec glm. I'm sorry, this is kind of confusing, guys. Glm vec 3. Yes, and I want it to be v3 map. Okay, there we go. Now we should have everything we need. Right and quit. Let's go ahead and put in the initial positions of all of the different objects in our simulation, and then we can go from there. So what we want then is positions dot pushback. Come on, I can spell this. Back. And we want to do what was it? I know that there's a couple different positions here. So I think the top corner one is going to be 1.0, 1.0, 0.0. It should be okay. Let's make that. Positions not declared in the scope. That is because it should be part of positions. And I think there's a weird bug here. I'm not sure exactly why, but okay. So based on how I wrote the make file, I have to make clean before making if I update a header file. I don't know why. It's just something I need to fix. I just, you know, make files. And, you know, they're good. They're good. Okay. So let's go ahead, yank, paste. Okay. So now we should have everything in here. 3 different positions. There should be also one at -1, -1. Another one at, let's see, 1, -1, and then a last one at, should be -1 in X and 0.5. There we go. Now, what do I want to do? I want in v3 map, we're going to say par.v3 map, and we're just going to say previous position. It's going to be equal to, oh, we need a couple different guys. So we can say previous position. This is the position of the object. Is going to be equal to this guy right here. And then we want temp 2. So let's go here. Let's just say temp, just because this is how I'm going to implement it, and I'm an idiot. Yank, paste, and then we're going to say acceleration. Okay. And this is just going to be 0, 0, 0. This should compile, I think, unless I screwed something up. And then we can pop down here and go into VI source and distributions.cpp. Pop down here to what we just drew. And instead of having this, what do we have here? Array of all the different locations. We'll still have the color array. The color array is good. But we don't need this guy anymore. We can just go down here and say par.positions for all of these guys. 1 second. So let's just add in par.positions. Hopefully I spelled that right. And let's, oh no! Ah, dag nabbit. I put it in the wrong spot. Whatever, let's do it. 1, 2, 3, 1, 2, 3, 4, 5. Okay, so 5x. Here, there, par.positions. There we go. And this hopefully should work, because I think we initialized the parameters before going in here. At least I'm like 90% sure, because I don't think we could go in here without initializing the parameters. Let's make that. And then we'll run SciVL. Where is it? Verlet. Oh, well, crap. That worked. Why? Ah, dagnabbit. Okay, so this means that we're probably calling on these guys. Part of that position 0. Let's do. Yeah, okay. Well, parameters have been set. Go over here, make clean, make. Did I do something stupid here? Let me try it one more time after make clean make and see what happens. Yeah, why is it seg faulting? Come on, GDB, SciVL, run with simulation Verlet. Okay, where's this guy? Gonna go here, do a backtrace, and we say that it is in distribution 752. Let's just go ahead and control D out of here, yes. And let's see, so it says 752. What? create circle, circle. What? What's the issue here? For some reason we're having trouble pushing back pushing back a vector. Let's see, what else do we have here? GL setup 69. Setup OGL? Yeah, it's probably there. So let's go here and let's do VI source, GL setup.cpp. Let's go to 69. Par OGL function. Oh, never mind. That's just what calls the appropriate function. Distribution 752. Yeah, par.shapes pushback circle. Why would we have a problem with that? Let's go back to calling this just array, and just to make sure it worked before. I think that was 13. Yep. And let's just put in array. There, 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 and here. Make that. Check to make sure it compiles. No, this one doesn't work either. Why not? It was just working a second ago. Did I do something stupid? Did I screw something up here? We have array here. Let me do a quick git diff of source distributions.cpp. Oh, of course there's gonna be a lot of changes because we changed them today. Okay, so let's go ahead and quit here. Let's clear. And let me see. Par.shapes pushback circle, 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 circle. We just did this. There wasn't an issue. We're creating the circle. We're creating some sort of time steps for the circle to be drawn in. And then we're pushing back the vector with all the different shapes in them. This should be okay. I'm just clean making again, because that's like the only thing I can think of right now. But it's not seeming to do anything. Why would we have an issue with par shapes pushback circle? Let me see, do we still have, no we do not. I'll run GDB on this in just a second, once it's finished building again. So we'll run GDB, scivl, let's see if anything runs actually. .scivl, let's just run -s fourier. Yep, this one works. All the others I assume should work too, std. Yep, okay, they all work. So let's pop in here and let's run Verlet. Yeah, that one seg false. Okay, well it seems to be the second pushback. What happens if we comment these guys out? Oh wait, why don't we try? Go over here and let's run platformer. Okay, this one still seems to work. Hey Zabata Mimuro. I'm sorry, I can never pronounce your name. I think I just settled to call you Zabata last time. But yeah, I'm fine. How are you, man? So let's go over here and let's do a quick, Quick what? What do I need to do here? Par.shapes push back. Let me go over here to, oh, let's run GDB. GDB scivl. Run with dash simulation Verlet. Let's take a look at these errors that we have here. Control C, Control D, yes. Oh, I forgot to backtrace. Do it again. R, S, Verlet, BT. Okay, now let's see what we got. Control D, yes. Okay, so it says Verlet, then it just says there's a problem with STD vector and the shapes and stuff like that. Yeah, I could use Valgrind. I haven't used Valgrind actually before. I should probably learn how to use that one. Let's see, what do we have? Bad allocator. Why? What's the deal? Like, why are you giving me trouble? Let's go ahead and comment these guys out here, because we know it's the second one for some reason. So let's see if we can at least draw the first one, see if we can glean any information from that. Let's go over here and make that. Where are we? scivl as platformer, of course that one works. So we want to run Verlet. Yeah, right? Verlet. Okay, index number is 0. I don't know what that means. Distributions.cpp, pop down here. Create circle, circle array 0, add keyframes, parse circle 0, 0.25. The array location should be... Thing is, it didn't draw this. It should have drawn this. What did we change recently that made it so it wouldn't have drawn this at all? C array. Wait, but this should be at some location. Let's go over here. Let's change, it should be 110. So that should be up in the upper right hand corner. But it's not drawing anything. And when it's done, we close it. It gives us the same problem it had before. Par.shapes is it's a global, I mean not global, but it's in a struct that we're reading in here. So it's being done in the same way that we do everything else. We're initializing it right, I'm pretty sure. How about we go in here? Why? What is the issue here? Unless we had a problem with one of these guys. Let's just comment these guys out. Go over here, let's make this. Oh, you know what could be a problem? Verlet par. What did we have before? We had the distribution test animation par. Par.end equals 0. No, this should be okay. Let me try something. Let's change this back so it's like literally what it was before. So we change this to test animation. What the heck? We didn't do anything. Okay. Before. Oh, wait a minute. I don't have resolution stored. That would do it. Come on. Do what I want you to do. Bar.dmap. I'm sorry, IMAP. Resolution. If I can spell anything, equals 100. Yeah, again, I told you this is kind of finicky. Make that. And run Verlet. You should be doing something. Crap! Was it not an IMAP? DMAP. Why did I put in a D? Whatever. RD. There we go. Okay, it's there. I'm sorry. I'm sorry, guys. I'm very sorry. I'm just very bad at life. You know, like... I'm sorry. Let's make that. Okay, well, we're getting there. If you do feel like using Valgrind SciVLS Verlet, nothing more to it. If it's the simplest case, do I have it installed? Valgrind. Well, okay, it's running now. But if it's that easy, I might try it next time. Okay, so, here's what we got. Here's the idea. I'm sorry this took so long. I'm sorry, I'm just bad at coding. Okay, here's the idea. These are planets, obviously, planets. This is our asteroid, and we want the asteroid to go to here, the finish line, by basically following the gravitational pull of the different objects, right? Super simple, straightforward, should be able to finish it, if not by the end of the day, probably by the end of tomorrow. So we should probably put in a finish line, but meh, we'll do that in a bit. Let's go ahead and get things working now, so let's see if the objects can at least move. Like, let's get our asteroid moving through the planets and kind of go from there. No, I don't know if this will work on Windows. Actually, I have no idea. It should work on Mac and Linux, no problem. I just don't really know how to run it on Windows at all. So, I'm not sure. Maybe... It's why I'm kind of keeping it just a visualization library instead of like a game library, because I know in the end, I don't know. I'm not going to be able to support all the different operating systems and such like that. I mean, I tried to keep it as general as I could, but I'm running Linux. I have a Mac that I can test off of, but I can't test off a Windows device. I don't even know how to really program on a Windows device. It's just complicated. So that's where I'm at here. Valgrind would have helped a second ago, probably, but here it probably wouldn't help so much. Okay, so now we have this guy, and we want to move this guy. So let's do it. We're gonna have to What do we have here? Where's Verlet function? Here it is. So in Verlet function, we have draw shapes. This is the function that we call every time step in the game loop, the loop that continues to go until end equals 1 or whatever. Okay, speckled lemon. Yeah. Okay, so what I want then is I want to create a new function that we're going to call every time step, which is going to move our object in some way, shape, or form. So how are we going to do that? Well, basically all we have to do is put it into this function here. So for example, for the Pong game, where's Pong? Pong. We should have like a play Pong game or something like that. Pong OpenGL. Yeah, play Pong with all the parameters. It's useful if you want to find a pointer. Hey Husky, what's up? Nasties and are too lazy to use a debugger like I am. Yeah, fair enough. I should try to learn more tools. I'm just very bad at learning tools. Okay, so what we want then is basically to go into VI include, and we want to go into, what is it going to be? It's going to be you mean efficient? Everything's great over here. I'm pretty happy to be back streaming. I'm pretty happy to be back into the internet game and stuff like that. It's good. Cat Blaster. Or if the codebase is a mess and not yours, but it's leaking memory somewhere. Yep. Been there, done that, but it's usually my code that's leaking memory everywhere. I want to go into include, and what did I call it? I think I called it aux function. So these are all the auxiliary functions, and I'm going to do a new set of functions. So we're going to want functions to move asteroid for Verlet. Visualization. We're going to need two different functions here. One is going to be find acceleration, and this is going to be, I think I'm going to put a Verlet in here, because I know there's going to be another visualization later that we're going to be finding the acceleration for. Like all compiled scientific software. Yep, I'm a scientist. Ampersand par. Go here, and then we're also going to want to do void move asteroid Verlet object. Screw it, that's what we're doing. Param, let's do it. I'm so bad at this. Okay, so we're going to grab these guys, and we're going to put them over here. So let's go into VI source aux functions. Pop down here to the bottom, and let's go ahead and put these functions in there. There we go. Job done. Completed. Some audio libraries that don't state what you have to free when using it come to mind. Yep. Malik, man. Okay, let's pop this over to this terminal because it's a little easier to see. Source aux functions. Pop down here to the bottom. Let's go and open these guys up. Okay, so there are functions that we have. Find Verlet acceleration should be relatively straightforward. However, there are a few things that I didn't take into account when I was creating these objects and stuff. So we have we have a couple different things here. So we have, first of all, the Verlet algorithm, which we've already written and is rather straightforward, right? Then we have an acceleration that we have to find. The acceleration is going to be found based on the gravitational pull of the different objects around. Now, here's the thing. Gravity, right, is gmm over r squared, like we had before. New page before. However, we have to make sure this object doesn't, like, zoom around. You know, we have to make sure that its velocity isn't particularly great. So its position, right, its change in position should be probably no greater. So how do I put this? Should be less than 0.01 in our movement frames. So this means, you know, we don't want it so big. So this means if we do our solution here, let's see, we have x is going to be x naught plus v naught t plus 1/2 at squared. Remove v naught t, assume it's not moving anywhere. Just as a ballpark estimate, x is going to be equal to square root of... Wait, what am I doing here? Change in position over change in time. But the change in time is like 1/60th of a second or something like that. So we want the acceleration to be Let's see, 1/60th of a second is what, 0.01-ish? So this is going to be 0.001-ish. We want x to be, we assume this is also equal to 0. So our acceleration is going to have to be like less than 10-ish. Yep. Back of the envelope calculation. Let's do it. This is not going to work out. But yeah, so we don't want the acceleration to be particularly high. We have multiple objects here. So what do we have? New page before. Here's an object, some sort of planet that we're working off of. Here's our asteroid. It's going to be r squared, so it's going to be some constant times the mass of the asteroid times the mass of the object here over r squared. R is going to be no greater than 1. Probably. It's going to be roughly order of 1 at most. So this means that this guy is roughly 0. This guy's roughly 1, because r squared is going to be roughly 1. So basically we have to worry about these constants here, m and m. Okay, yeah, that's fine. Now, the issue is that we also have an initial velocity to move the object with, but let's move everything one step at a time. So first let's get this guy moving around, and then we'll worry about everything from there. Okay, so we have I think this is good. So that means we have some sort of mass of the different objects, and we just play around with these masses. I think we're okay. So what do we have here? Find Verlet acceleration. Should be relatively straightforward. So we'll say, okay, now hear me out, guys. I know this is really kind of a crappy way to do it, but I'm going to go into VI source, and I'm going to go into distributions, which is where we set everything before, and I'm going to go down to the Verlet parameter set, and I'm going to push back some weights here. So let's do 10. Actually, yeah, 10. 10. Let's just make them all 10. Except for this way. Here's 1. So what I'm going to do is, because we're not using a z-coordinate here, and I know this is really hacky, but because we're not using a z-coordinate, and we have vec3s, and we need a mass for every one of the objects, I'm just going to put the mass at the bottom of everything else, and hope everything's okay. That's what we're going to do. So what we want is 4. Let's see. I equals 0. I less than par dot shapes. What is it called? Par dot positions dot size plus I pre-incrementing to, because pre-incrementing. And now all we have to do is find the acceleration. So we'll say up here, GLM vec3 acceleration, and we're just going to go ahead and set it equal to 0, 0, 0, and then we go down here and we say, can we add vec3s? We'll see what happens. I'm not really sure. I don't know how the GLM library works, so let's go change this to GLM because, typo alert. Thanks, I just caught that. Appreciate it. Okay, so what are we going to do? I'm going to say part.positions.size plus I. Now we just have to find all the accelerations. So we have all the accelerations, I think. So we're going to say acceleration plus equals... and we want to do part.position size minus 1. We don't want to go through the last one. So we're going to say part. Shoot, what am I doing here? So it's going to be acceleration is going to be equal to. Now we need some sort of change in position. Okay, I got it. So first we have to find a radius. So GLM vec3 r rad, we'll call it. It's going to be equal to, again, 0, 0, 0. And now we're going to find the radius, and then it's going to be easy from there. So rad is going to be equal to, what do we want here? Par.positions. Then we want to do minus Oh, what am I doing? Why am I so bad at this? Par positions I minus par dot positions of par dot positions dot size. I think we're probably gonna have to put a -1 in there. Yep, -1. And some guys here. There we go. Great. Yep, that's totally gonna compile. Yep. What? That's what it caught on? I forgot an int? Since you have an IRC client open, does it do... I don't know what that is, but apparently not. I apologize. What does 2C304L... What is this? I'm not sure what that is. So let's go down here and let's say acceleration is going to be equal to... we have all the different positions here, so it's just going to be some sort of constant, which we don't have right now. No fancy colors. Oh, yeah, I'm sorry. It's a terminal, right? And it's a very stripped down terminal. It's actually the Sakura terminal. It's the, like one of the faster terminals in that it has no bulk to it whatsoever. It's rather simple. So the acceleration is going to be something over radius, so it's going to be, par dot positions of I of 2 over rad. Yep, that should do it. Now let's just go down here and we'll say par dot v3 map of acceleration is going to be equal to acceleration. Okay, so now we have the acceleration. I use RSSI wall. That did nothing for me here. I run it in console. Oh, okay. So it could just be that I'm using IRSSI. I could try different chats, WeChat and Hex chat. These are things, maybe. Let's look at these. Hex chat. Oh, that didn't do anything because I didn't click the button. Hex chat. Here we are. I see. And then we want WeChat. WeChat. Okay, WeChat. I want it to be terminal based. If it's terminal based, that's okay. Yeah, it's not a big deal. I just wanted a terminal based IRC client to work with because I'm a big fan of terminal based things, as you can see, like my entire thing is a terminal. Okay, so now we just have to move Verlet object. Okay, this should be relatively straightforward. So what we need then is the object's location, right? So we know that it's the last object in the shapes vector. That's okay. And we also know it's the last object in the positions vector. So then what do I want to do from there? I want to do terminally ill. Yep, I have made that pun multiple times, actually, and I don't feel bad about it. Okay, so now we have the relay object here. So we have the shape's position. We have the acceleration. We have its new position. Good, so that's what we need to do. This is going to be following basically exactly what we had before. Ugh. You have not been introduced to my chat yet, guys. It's literally a bunch of weird puns that make no sense to people who don't understand programming. I'm going to go into VI. I think it's going to be Simuleos, and I think it's going to be Verlet, and should be Verlet.cpp. Yep. Okay, so here's basically what we're doing. We have some sort of DT, which I failed to add in. I'm going to have to add in a DT. So let's do double. DT is going to be equal to par.dmap of DT, which I'm going to have to remember to add, because otherwise this is not going to compile. Let's go ahead and do it now. VI source, distributions, and let's pop down to Verlet par. There we go. And let's just do paste here and do a DT, and I'll put the DT as 0.01. Just for the sake of the argument. It might have to be smaller, not sure. So now we're going to go back to aux functions here. So we have a DT. Position. Oh, that's just the position of the ball. So we already have the current position of our object. So now we just have this loop. So we're going to say total time. Do we need total time? I don't think we need total time at this point. So we want to do temp. Oh. Yeah, so let's do par dot v3 map I hate this notation. I'm really sorry about that, guys. Of temp is going to be equal to par.v3 map of oh, it's current position. So actually this should be, I'm sorry, this is kind of confusing. It's always confusing. I apologize for that. So let's go up here. Let's create a couple of different variables. We're going to do int, actually this should probably size t. And we want index is going to be equal to par.positions.size -1. Let's do par.positions of index. There, something like this. Wait, did I use that for anything? I think I used... Wait. What do you mean seeing... Oh, shifting left. Oh, yeah, I see what you're saying. Yeah. It's C++, so it's used for, yeah. I agree. You're talking about over here with the C out. Okay, so we have the different positions here. We say the new position, so par.positions of index is going to be equal to 2 times current p, which is going to be 2 times par.positions of index minus previous p, which is going to be par.positions of, oh no, par.v3 map, one second, I think I just called it previous p, something like this. Then let's pop down here and just do plus par.v3 map acceleration times dt times dt. And then we just go down here and we say par.v3 map of, oh shoot, what do I want? Of previous position is going to be equal to par.v3 map of temp, something like this. Yeah, that should do it. Okay, what do we have here? Streams I don't like, one of the worst of SCD, especially when CPP shifting operator. Yes, I agree. It's really confusing, but that's how it goes. Okay, so we find acceleration, and what I want to do then is write this, and then I need to move the shape. So we know where the shape is. So let's do move shapes, shape, and let me go into shape functions over here. Oh wait, let me check to make sure I did this right. We move time forward, that's fine, dt. We have some sort of dt. We say temp, right? Current position equals its current position. Then we say position is equal to Verlet of current position, previous position, minus 10. Oh, that's the acceleration. And 0.01 must be the dt. Yep, I don't know. Yeah, fine, dt, fine. Then we say previous position is equal to current position equals temp. Yeah, so this should be okay. And then we output the positions, but that's okay. So now we have to move shape. Let's quit here. Oh, wait, let me also check the Verlet guy. So 2 times current position. Yep. Minus previous position. Yep. Plus acceleration times dt times dt. Yep, that should be okay, unless I screwed up something. So now we want to go into, what do I want to go into? I want to go into VI source and shape functions. And let's go into move shape. Here we are. Okay, it takes the shape and then the translation vector. So we have to make the translation vector. Do you never get tired of pressing space for those spaces instead of setting up tab to insert the spaces? Yeah, I can also set auto indent if I want. So this means that the next time I press open, it does this thing here. Like I can do this. That's not a problem. The problem is I've gotten bitten in the butt so many times from this that I just prefer to press the spaces, because every once in a while, like I set auto indent, and you know it screws something up. You know, like I'll paste something from somewhere. Or the one that gets me is one of the vim commands that basically makes it so like if you put in a comment, let's say, the next line will automatically already be commented. So if you're copying code from somewhere, one second. set no AI. So if you're copying code from somewhere, it just screws up, you know? It does work in VI. Yeah, it does. I know it does. I just, I don't know. So now we want to grab the shape. So we want par.shapes of index. I'm going to move this shape. So we're going to say translation. So we'll say trans, which is what we'll call it. So now let's create the translation vector. So we'll say glm vec3 trans is going to be equal to, and it should be a subtraction between the previous position and the current position. So we should have a previous position and current position. So it should be par dot, wait. But I'm pretty sure there's a setting somewhere to disable it. Yeah, maybe. I don't know. I have trouble with some stuff. Sorry about that. Setting for everything. There was okay. What is it? What is it called? Silicon Valley. There's a show called Silicon Valley. And this show had this one date scene. I don't watch Silicon Valley too much just because I'm not in the US and I have trouble watching television nowadays. But in fact, I didn't even watch television that much when I was in the US. Regardless, doesn't matter. There's this one scene where this guy was sitting on a couch and he was with this girl, and the girl, every time she would indent, would press the spacebar 4 times, and the guy just went completely ape, like he just went crazy. He was like, I can't deal with someone who would use spaces instead of tabs, and it was kind of fun. I enjoyed it. I'm sorry. So dude, let's pretend I'm talking. Previous P. There we go. Minus par.positions of index. And I just realized these probably need to be switched. So let's go ahead and do the $sign here and paste it here. And oop, that. Paste it there. Minus A. Sorry for the sneezes, guys. And semicolon there. If it compiles, obviously we are all good. Make that. Everyone can do whatever they wish, unless in a project where something has to be agreed. Yeah, I misspelled trans. That's fair enough. And yeah, make this guy. See what happens. Apparently I messed all this stuff up. Yep, that looks like I messed stuff up. Let's go ahead and clear. Let's make that. See what we got. Okay, what do we have? All right, there we go. Thanks for all the errors, C++. Appreciate it. You're great. Yep, there we go. Okay, so the error is no match for operator star. Oh, fine. I feel like I should have taken time to watch the VOD leading up to this. Sorry. As long as they don't mix tabs and spaces, because that triggers the mixed indenting warning. Gonna love Python where white space is part of the syntax. Oh my word, there's so much stuff, you know, that just make files. Make files drive me crazy because you have to put a tab in make files. Like if you don't have tabs, it's not gonna work. And the problem is when I copy, sometimes I'll just like, you know, highlight the make file and I'll put it into the make file. And it's fine. But the problem is, because of the way that I copy it in this terminal, and this terminal automatically changes it to spaces when I do the copy. So, I don't know, fine. Okay, so the issue here, let's go here, let's add in a semicolon, and now we'll say, how are we gonna do this? Let's go ahead and create a new vec3. Every single time when Python, I have a return with an extra tab somewhere, it quits out everything. What do I want? I want to do another vec3 in here somewhere. So let's say glm vec3, and we'll say molt x, and over here we'll create molt acceleration. So we'll say molt acceleration is going to be equal to, I think we can just do this. Par.v3 map. Oh, I hate this. This is ugly. It's ugly as crap. DD here. Pop here. Add an acceleration there. Do acceleration is equal to par.v3 map of acceleration. There we go. Down here, let's go ahead and add a space just because I like adding spaces to things. Every single time, Python should have gone with forcing either one, but not allow both. Okay, let's go down here. What do I want? I want to say... What do I want to say? What am I doing? Did I do anything? Molt. No, okay. Plop down here, let's go ahead and create... There's a temporary position, so let's go up here and let's say molt acceleration is going to be equal to... and it should just be x times dt, acceleration.y times dt, and acceleration.z times dt. Actually, I just realized I'm probably not allowed to do .x, y, and z. I don't know why I thought I could. So let's just change these to 0, 1, and 2. I don't know what I'm thinking. Let's go over here, and let's do it. 0, 1, 2, 2, 1, make... Dagnabbit. That's because I didn't change it down here. So we're going to want to do the $sign and add in molt acceleration. Make that. Good. That's how it says 4 spaces should be used, doesn't it? Probably. Let's clear a couple times. We're talking about Python. And now let's make that. Give it a second because error messages don't take long to appear. But when they do... What do we have? It says... No match for operator star. 1 second. 154. 2 times par.positions index. Oh, I'm gonna have to do that there too. Dag nabbit. Okay. So we're also gonna want to do to position. Man, this isn't all of a sudden this is confusing as crap. So we're gonna say and position. So we're gonna say position is gonna be equal to par.v3 val of position. I should just create the operator. Screw it. It's too late. So molt acceleration. Now we're gonna say to position. I can't obviously put molt position. Molt position. Screw it. Copying this guy. Go down here. Change this to a pose. Over here. Change all these to pose. Change all the DTs to 2s. And... because subtraction seems to work, right? And then we want molt position here. And let's just go ahead and add in... Wow, I screwed that one up big time. This there. D, whatever. Make that. V3 map. I'm gonna have to comment this like crazy to get it to make any sense whatsoever. Okay, so grabbing necessary values. Okay, looks good to me. Then we're gonna say creating variables for Verlet integration. Down here is the Verlet algorithm. And then down here we say creating translation vector and moving shape. Okay, that should do it. And up here, what do we have? We say finding acceleration. Actually, I think this is straightforward, but I'm just going to say finding acceleration to find something like this. Okay. Wait, I missed something. Renegade VI, though Google has updated theirs from 2 spaces to 4 spaces, according to their current site. I feel like I missed a lot of stuff. What do we have here? There's There's some projects where the style guide state use tabs for indenting and spaces for all highlighting. Worst thing ever. Dagnabbit. Style guide, not equal layman language syntax rule. Of course, for all in all, Google has updated theirs from 2 spaces, 4 spaces. Bohr in turn had to port all the existing code base. I think 2 to 3 will do for you, even if you aren't doing 2 to 3. Considering Android sources, Google mostly have interns programming. Let's go over here. VI source. Distributions.cpp, pop down here. Verlet par and previous p. Okay, let's go over here and let's run scivl. Whatever. Scivl-s Verlet, and let's watch it break. Okay. Well, the reason it didn't break is because I didn't put it in here. So draw shapes, but what we also want to do is in here we want to say, 1 second, source, aux functions, just realized I screwed this up, move Verlet object is what I want, and in here I want to say, find Verlet acceleration bar. So now I want here, and I want move Verlet object bar. Okay, let's see what happens. Alright, happy Lorat. My ability to do programming has been reduced to the point of negative returns. Time to go to sleep. Been there, done that. Good luck, man. Considering Android sources, yeah. So let's see what happens if we run. Alright, look at that. It's great. It's great. We have an object moving. It is way too fast. Talking about Android, how is the migration from Java going on the platform? I hear all the time talk about Google wish to replace it with Go, Kotlin, and I know Microsoft pushing their .NET. All right. Great. All right. Quite happy with this. Okay, let's drop the time step. That's not what I wanted at all. Let's just drop the time step a couple guys here. Let's make this. Dang it, why is it? Why? I thought dropping the time step would help here. What if we drop the masses of all these guys to just 1? No, that shouldn't do it. Yeah, it's still. Why is it bouncing back and forth? Why? Okay, here's the thing. This guy. What is this doing? It's just. What? It's just moving. Look at him. I don't know. He's blinking around. Why is it appearing like this? What? It's like. It almost looks like it could be doing something reasonable. It's just flipping back and forth between positive and negative 1. Why would it be doing that? Huh. Okay. Not sure. So, let's see. It's Tuesday my time. Okay, yeah, we have all week to fix this. It's fine. No problemo. Why? This is stupid, I'm sorry. This isn't gonna help any. Yeah, the ball's not even there anymore. I don't know what happened to it. It's gone. Ah, man. Okay. It's fine, it's fine, it's fine, everything's fine. I'm gonna guess the acceleration is too high, alright? But the thing is, if we guess the acceleration is too high, let me just make this again. Let's see what we have. Here's the problem. If we have an object... Oh, where did it go this time? It's not even there. Doesn't lowering DT increase the animation speed? Acceleration is going to be determined... Let me think. No, I think it should decrease it in the end, because the Verlet algorithm works like... right, so we have an AT squared in there. And the x position is dependent on at squared. So if we drop dt, this term goes lower and lower, basically to 0, right? So that was what I was trying to do. I was trying to drop this guy down to 0, so that basically the current position here, 2x0 minus x0 here, would basically be the same. So like the next position and the position it's currently at would be basically the same. Oh, cancel. Okay. Let me go into distributions here. Let's go into Verlet position. Sorry, Verlet par. I assume that dt is the time between frames. That's possibly what I got wrong. Yeah. So dt is not the time between frames. I actually can't dictate that, which is something maybe I should look into. Well, no, I dictated the time between frames. Every frame is 60 frames per second. So the next frame will appear at 1/60th of a second after. Let's try this to 0.001. I want to get that weird thing again. Yeah, where'd the ball go? Okay. Not a problem. I don't know exactly what happened. Let's remove this for now. Make. Yep, okay, there's the ball. Great. Still exists. If dt is equal to 0, let's see, previous position is equal to, we should just set this equal to par.positions of par.positions dot size minus 1. Okay. See what happens if we write this. Make that. If dt is 0, this shape should not move at all. It doesn't even appear. Okay, great. Why doesn't it appear? Good question. Thanks for asking. Okay. So, par.positions, par.size 1. I'm sorry. Let's go here. Let's write and quit. Aux functions, pop down here. Okay. Move relay object. Basically, we find the acceleration. If the acceleration is equal to 0, then basically all we're doing here is we're saying par.position size minus 1. Here we say 2 times. Yeah, this should not move at all. Make that. Okay. Okay. I don't know where it's flashing to. I don't know why it's flashing, but it's not moving. Why is it flashing? I have no idea. Is this because of how I'm moving the shape? No, it can't be how we move the shape. Okay. Why would it flash? Par.positions index. I'm sorry. I just can't figure this one out. Par.positions index is equal to multiple position, which is going to be 2 times the position. Okay, minus par.v3 map previous position. Great. Times the acceleration. This guy's 0, right here. This guy is whatever it was before, which is the same as what it is currently. So we're basically doing 2 times x minus x, which is going to be equal to x, if that makes sense. Yep. Let me do something stupid here. Let me do std cout translation vector here. So I want to do trans of 0, new tab, trans of 1, new line. Okay, this is going to output a lot of crap into the terminal, but I just want to see what happens. I forgot a thing. Make. Okay, what is this nonsense? So it's 0, 0, and then negative 2, 1. 0, 0, 2, negative 1. 0, 0, negative 2, 1. Okay, it should be 0, 0 constantly. So what is happening here? We are translating the shape. We are, yes, the vector keeps flipping, But the question is, why does it keep doing that? Mult acceleration, v3 map temp. We're setting some sort of temporary variable, and we're saying it's equal to the current position. Figured it out. Nope, I didn't. Dang it. Thought I did, but I didn't. Index is part of positions dot size minus 1, which should be correct. That should be the last element in our vector. Okay? So now we say part of positions of index. Part of positions of index is equal to multiply times the position. Position. Part of position. Oh, does that exist? Position is equal to par dot positions of index. Make that. Well, okay. So part of positions of index should be the position here. Then we say position 0 times 2, position 1 times 2, position 2 times 2. That should be okay. Positions of index is going to be equal to whatever it was before. Hey DN98, I saw your YouTube video of the stream yesterday, so glad that you started streaming again. I won't be able to follow the live streams, but I make sure to watch them later. Ciao, have a good day. Hey DN, thanks for coming in. Yeah, so I'm going to try to put all the streams up on YouTube from now on. Just, I'd been missing it, and I think it's a good thing to do. So don't worry about it, it will be live, it will be up basically an hour after this stream is done. Something like that, pretty much every day. So, well, every day I stream. I might miss like weekends or something like that for streaming, but for the most part I want to get back to some sort of regular content most of the time. So we'll see how that goes. Okay, so now the question is, and also I appreciate the fact that you appreciate the content I'm putting out. I'm actually quite happy with that. So thanks for watching, and I will see you around, because you said you gotta go. So yeah. Okay, so next, what I want to do. Why is it flipping? Good question. Okay. It's flipping -2, 1. But why would it flip -2, 1? Size t index. What if I'm doing this wrong? I feel like I'm not, but yeah, of course I'm not. Yeah, that's correct. -1. Okay. So what do we have here? Part of dmap dt. This should be okay. Positions index should be okay. Wait, why am I just... There we go. Got it. Okay, so now we want to find Verlet acceleration. And we want to go into VI source distributions and pop down to Verlet par. And we're going to change dt to 0.01. Go over here. Nope. And go into write and quit, VI source, and we want aux functions here. Pop down here to the bottom. And I do not want to output anything anymore. Where am I outputting stuff? There it is. See out. Let's go here, make that, and see what happens. But now watch it burn. It probably will. Verlet. Okay. Where did it go? Let's drop dt to be incredibly small. VI distributions, G, and let's just do, where are we? Oh, that wasn't what I wanted. Make that. Fine. VI source, aux functions. Let's see what's actually happening here again. STD, cout, trans of 0, tab, trans of 1, tab, new line, sorry about that, end line, make. Now let's see what happens. I don't know where the ball went. It just wasn't there. Verlet. Okay, that's actually expected then. So what basically happened was, let's see if I can go up here. We had a very strong acceleration, and that acceleration was equal to 5, -6. So its change in position was incredibly high. So this just means, for some reason, it's just moving too far. Which can be offset by... Actually, what happens if we... Let me try a couple things here. Let me do distributions. Let's do... I don't know what I'm doing here, so Verlet par. Let's change this really, really small. Make that. And let's see what happens. Okay, that's identically 0 all the time. I don't know why. Make that. Okay. Close out of here. Oop, come on. See what we got here. Well, this is odd. Oh, no, maybe it's not so odd. Okay, it's moving way, way, way too far. So let's just drop this down here. Go into VI source, aux functions, and let's see, there should be find acceleration or something like that. Okay, so what we want then is positions of I here, divided by radius, but the radius we want... part of positions 1, 2. Wait, what is this doing? Part of positions of I, 2. Oh, that should be the weight. Okay. So that's the weight. So let's multiply this by 0.001. Make that. And see what happens. Oh, actually, wait. Let me see. Was it times e to the... Oh, it is e to the -5. Yeah, shoot. You're right, you're right, you're right. Distributions.cpp, pop. I didn't realize it was e to the negative something. Okay, so let's see what happens if we write this. Go over here, make it. And let's do S here. Okay, control escape. And it looks like we have... Oh, that one should work. Relay. Yeah, but the object doesn't show up. Okay. Fine. Fair enough. This is a translation vector. So this guy's actually moving upwards. And, oh, it's moving in X. It's moving the wrong direction. Okay, so I think it's because it's moving in X that it's just off to the left of the screen. So let's go here, right quit, go into aux functions. Let's go down to find... Let's quit. Let's open it up again. Find acceleration. And I think what we need to do is, let's see, part of positions of I2. That should be a weight, right? Can I not put a negative sign in here? Make. Now let's do... Wait, did that not go through? Make. Savio Verlet. Oh, never mind. I think it was moving in the right direction anyway. Okay, so what is this doing? This means that it's moving to the left. This is... Oh, what is this? This is 1,000 Skins Josh Woodward. I like Josh Woodward's music. Sorry about that. So, yeah. Well, let me just go ahead and plug him since he's a cool guy. 1,000 Skins, Part 1, Josh Woodward. Josh Woodward has all of his music available, Creative Commons. Here. And so, if you're interested, here's his music. He's quite good. I don't know, I like him for a lot of reasons. Yeah, I changed the music around too, since I left. Okay, so what is this doing? This is saying that we have... This is saying that we have an acceleration or a change in position that will be to the left and up. Is that what we want? To the left. We definitely don't want it to be to the left. We want it to be the other way. So let's change this right here and make that. Let's do S Verlet. escape from here. Okay, so this is saying it is down, because that's Y, and to the right. That's what we want. Let's also output its actual position. So let's do, how about we just do par.positions of index, and do the same thing here. Make, and see what happens. Okay, for clarity, trans is the final translation vector for the object. Now far as 1 unit on the screen. The screen is between -1 and +1. So -1, +1, -1, +1. So we don't want this to go beyond that value, right? The issue is, it does definitely go beyond that value. Here we have, it's basically at -1 in x already, and we find an acceleration. Yeah, so look at these positions. These positions at the end are off the screen, definitely off the screen. 6.404. So let's do distributions.cpp, Verlet par, pop down here, change this to make relay. Okay, right here, we should be basically at the position we were before. -1, basically, and 0.5. But the object isn't showing. Why not? Well, let's go back. Wait, why wouldn't the object show? Because it did show before. Right? Let's go into, again, distributions, Verlet par. Change this to a 0 exactly. Make that. S Verlet. Yeah, it's not appearing, which is okay. But the question is why? Why is it not appearing? No, this isn't okay. It's not okay that it's not appearing. So let's go right quit. Aux functions here. G. We're outputting its location. We're moving its location. But I swear it appeared a second ago when we... Remember, we just did this. We didn't find the acceleration. There it is, right there. It's right there. But when we find the acceleration, it doesn't appear, but the translation vector is still is basically 0 at the same time. So why would finding the acceleration screw anything up? Let me see. Yeah, I'm not exactly sure why this would do anything. So let's just grab this guy, put him in here. Okay, acceleration is equal to 0. Let's comment this guy out. This guy out too, and this guy out too. And let's make this guy. GLM Vec 3. Where are we here? Acceleration. Make. And let's see what we get. Yeah, okay, so this one doesn't appear. Okay, so there's something weird that we're doing here. I'm just not sure what it is. Okay, that's fine. Okay, we've singled it out to be in the find Verlet acceleration function, basically. So we know that it works. Like, nothing happens if we don't use that function. So now the question is, why? Okay, pop in here, remove these spaces there, delete some lines here, Go over here. What's up with the acceleration? No, all we're doing is finding the acceleration. That's it. Let me think. The position isn't changing. Translation is incredibly small. It basically 0. Part of position's index. Part of shape's index. Its position is -1, 0.5. Should be okay. Okay, I'm going to do something stupid here. I'm going to say find Verlet acceleration. Then I'm going to say this. Here I'm going to comment this one out, paste, and I'm going to set it identically equal to 0. Okay, so there is no acceleration. We're going to make this. We're going to run it. It appears. Okay. If we set this equal to something, like let's say 0. Okay. I think I figured it out. Down here we want acceleration of 2 to be equal to 0.0. Let's go over here. And let's remove this guy here. Go over here, remove that, make that. Acceleration was not declared in the scope. That is because, what? Part of V3 map, acceleration equals acceleration. Oh, that's because I removed the wrong line here. Well, let's get rid of that. Part of V3 map, this should work. Make Verlet. Okay, that's a thing. Seems to be existing, which is great. Let's remove this. Move shape. Go into distributions, Verlet par, and let's change this to 0.001. Make that. And we have Verlet. All right, that looks like it could be doing something correct. I'm okay with that. Okay, so what we want then is let's make the just to check something. Let's double this, and let's make that, and let's do that. Okay, let's times this by 10, and let's make that. I'm really expecting this guy, unless I'm doing this wrong. This is 1, 1, yeah. Let's do 1,000. Make. Come on. Why is it not doing anything? Are you changing the mass of the moving object or the other one? I'm changing the mass of this guy right here. I wanted the mass of this guy to be incredibly high. Make. But it seems to be doing the same thing every time. Okay, fine. We'll keep this at 1. Because it doesn't seem to change anything. Make. Relay. Yeah, why is it doing the same exact thing? I don't understand this one. But, you know, we have the object moving. We're getting there. Yes. VI aux. G. Up here. Okay, so here's how this one works. We say we have some sort of position that is the okay, here's the current problem. If I run this guy, okay, we have a ball that's falling. However, all 3 of these objects are massive objects. What I wanted to do was make this object incredibly massive, so the ball is accelerated here towards this guy. Right? That's what I wanted. What's happening is, sorry, it's not quite that. You overwrite the previous result in every iteration of the loop. Yes. Let me think. Why would we have to add it? Acceleration. No, we find a new acceleration at every point, right? The acceleration is equal to... Shoot, you're right. This needs to be a plus equals, is what you're saying. Yeah, I see what you mean. I misunderstood. Make... Don't know what happened to the ball, but I think this is correct. Yeah, kind of. It's something like GMM over R squared. It is something over R squared. That's true. Now, where'd the ball go? Dagnabbit. Let me try this again. Index of 0 par dot positions of index 1 new line. Right now the larger balls don't really mean anything, but they will in a bit. Just for now, I'm just kind of testing things. So let's go ahead and make this, and let's see what we got. Okay, that's not a number. That's definitely not a number. Okay, why is that not a number? That is not a number because the radius must be basically 0. Then somehow, why would the radius be 0? There's something we should probably talk about then. Radius is equal to 0 up there. So this means we are subtracting 2 points that are at the same location, basically. So par dot positions of I minus par dot positions... Wait. Par dot positions of I should never hit par dot positions of par... Right? We should never hit the point where we have the two objects at the same location. I don't think. Okay, well this is something we need to fix. But I think I'm gonna go ahead and close shop for now. And we'll come back to here, and what we need to do... let me set this equal to what it was before. Well, anyway, you guys saw the visualization. We have the 3 planets, and we have the ball that's moving through the 3 planets, and we want the ball to basically go through the planets, and we want to, like, be able to manipulate it a little bit. So, I think what I'm going to do is I'm going to close up shop here, and we'll hit this again tomorrow, and we'll try to figure out exactly what the problem is. I wanted to go to the gym before going to work, so I think that's what we'll do. For now, what I'm going to do is I'm going to go ahead and commit what we have, so that you guys can play with it if you want. Obviously there is an issue with it, but that's okay because we're on a beta branch. So let's do get status, and let's do get add include star source star, and let's do get status again, and let's do get commit dash m adding, let's see, Verlet case, let's say comet. Is that how you spell it? Comet? Let's say asteroid. Moving through planets. More work to be done here. Okay, now we're going to do git push origin beta. Too late, called it asteroid. Good. And done. Hey Arcane, unfortunately you came right at the end of stream. I am heading out now. It's 7 o'clock in the morning my time, which is typically the time we end the stream. So, before I leave, I want to say a couple things. First of all, this is a test of the Verlet algorithm, right, just to show that it works. pretty sure the Verlet algorithm works because it works, right? But I need to make sure that the asteroid's moving properly through the planets and everything like that. So we'll see how it goes. Few things left to do. We need to figure out why the acceleration isn't being found appropriately. That should be a quick fix tomorrow. It's probably just a typo somewhere. I don't think it's going to be too hard. Then we need to basically shoot the asteroid with some sort of positive velocity so that we can move it to like the finish line, right? So we should be able to move the asteroid up and down, and we should also be able to shoot the asteroid with some sort of velocity or something like that. So that's kind of what I want to do, and then we need to add in a finish line. I think it's all doable by the end of the day tomorrow. So the schedule kind of looks like this. I want to finish up this visualization probably by tomorrow, maybe Thursday, write the algorithm archive article on Friday, and then on Saturday I'll make the videos to put up for Sunday. And that's kind of what I'm looking at. So I think that's what we'll do. And that's about it. So thanks guys so much for coming in. Have a great day, night, afternoon, morning, evening, whatever time it happens to be your time. And I will see you around next time for the next episode of Simuleos when we finish up this visualization, hopefully turn it into a little bit of a game, and then we go from there. The command is /scivl -s for simulation type, and then Verlet, which is the simulation that we're running. Obviously it's not quite there yet because we have all these nans to work with, but we're getting there. We're getting there. It's getting there. So guys, thanks so much for coming in, and I will see you next time. Bye guys.